a gas has a density of this at 1 atms and 273 degrees Kelvin, what is its molar mass? Now, to solve this, first of all, I'm just going to derive the equation for this. So you know the ideal gas law, right? PV is equal to nRT. Now, instead of N right over here, N represents basically moles, right? Instead of moles, I'm going to substitute N with grams divided by molar mass. Because guess what? Grams has the units G, right? And molar mass is in grams per mole. So the grams just cancel out, and you're just going to be left with moles as the unit, right? So essentially, grams divided by molar mass is just equal to the amount of moles of whatever you have. Now, let me find a way to incorporate density into this formula. Recall that density is equal to mass divided by volume. Okay? So in this case, the mass unit that we want to use is grams, right? The mass unit that we want to use is grams. And then the volume unit that we're going to use is this V right over here, right? We have the V already in the formula. So we want to get grams and divided by volume on this side of the equation, right? On one side of the equation. I'm going to do is I'm just going to multiply both sides by the molar mass, divide both sides by PV. So I get the molar mass is equal to grams times R times T divided by PV. Notice how now grams and volume are on one side. So this right over here creates density. So I'm going to get the molar mass is going to be equal to the density times R times T divided by P. So that is the formula for it. So now we can just plug it in. The gas has a density of 1.43 grams per liter at 1 atms. So in this case, 1 atms, that's going to be my pressure. It's going to be in the denominator. Recall that R is the ideal gas constant, so that's 0.0821. That's moles. Sorry, not moles. Liters times atms divided by moles times Kelvin. Sorry, moles times Kelvin. And then this is going to be multiplied by our temperature. All right. So Kelvin cancels out. Let me see. The liters cancel out. Does ATMs cancel out? Yes, ATM does cancel out. So we're going to be left with grams divided by moles, right? Because grams is in the numerator. Notice how mole is in the denominator of this fraction, right? So we're going to be left with grams over mole. And recall that molar mass is essentially just how many grams does 1 mole of whatever you have weigh. So, that's how we know we're doing the correct calculations, just checking the units. Now, we could just substitute it in. So 44 grams per mole, that's going to be equal to the gas constant multiplied by gas constant. That's going to be liters, ATMs, mole Kelvin. And this is at 300 degrees Kelvin. And this is going to be divided by the pressure. And then the pressure is 1.50 atms. All right, so our unknown is density. That's why I put an X there. And we just substitute it all there, and then we just solve for X. Okay, so for my calculator, I got the density, which is equal to mass over volume. Right, so basically the density, that's going to be equal to 2.68, and then that's going to be grams over liters. All right, that's the gas, and which gas out of all the options is it. So we're going to try to use our formula over here. We don't know what our molar mass is, so I'll just put an X there. What is our density? In this case, remember, density is mass divided by volume. So we're going to have our mass divided by our volume, 2.00 liters, right? So then our density is just going to be whatever this comes out to. So that's just going to be 2.25. All right. Our density is going to be equal to 2.25. And then after that, this is going to be multiplied by, actually, just split grams per liters. This is going to be multiplied by our constant. So this is going to be 0.0821 liters ATM. Here's ATMs, moles over Kelvin. And then this is going to be multiplied by our temperature. However, notice how our temperature needs to be in Kelvin, right? In order to cancel out the Kelvin from our ideal gas constant, we need our temperature to be in Kelvin, but it's in degrees Celsius. To convert from Celsius to Kelvin, we just add 273. So then this is going to be 298 degrees Kelvin. So it's going to be multiplied by 298 degrees Kelvin divided by pressure, that's going to be 1.2 ATM. 1.2 ATMs. Kelvin in numerator, ATMs in numerator, ATMs in denominator, that cancels out. Kelvins cancel out. Let me see. The liters cancel out. So we're just going to be left with grams divided by moles. Now that we have our density, which is 45.9 grams per mole, we can just check our answer choices. So which gas is this? Which gas has a molar mass of 45.9? Nitrogen has a molar mass of around 14 grams per mole. Carbon has a molar mass of around 12 grams per mole. Oxygen has 16 grams per mole. And then hydrogen has around 1. These are like common sort of molar masses that you don't have to memorize them, but it's very convenient to memorize them. Anyways, nitrogen, there's 2 of them. This is 28 grams per mole, so it can't be A. Oxygen, that's 16. 16 times 2 is 32, so it can't be this. CO2, carbon dioxide. So we know 2 oxygens, well, 16 times 2 is 32, and then that's going to be plus a carbon. Carbon's molar mass is 12, so that's going to be 44. So comparing that to our 46, that's not going to be it. Ethylene vapor, so that's C2. So 2 carbons, that's going to weigh 24 because 1 carbon weighs 12 grams per mole. Then we have 6 hydrogens and we have 1 oxygen. So this is going to be 30. 30 plus 6 is 46. 46 is awfully close to this, so it's going to be D. You'll find that if you do propane, it's not going to be close. This is going to be 36 plus 8. That's going to be equal to 44 grams per mole.